Hi everyone, how's it going? If you are watching this sometime in the future, not live, um, this is an R tutorial about gganimate. We do this stream every Wednesday at 5 p.m. Chicago time, so coming out with us live, get your questions answered, um, hang out in the chat. It's a lot of fun. So, okay, let's go ahead and get started here. My goal this week is to talk about gganimate, which is a package that makes doing animations much simpler than it otherwise would be. Um, I think that a lot of people who sort of make a lot of plots potentially undervalue the usefulness of animation for showing ideas. So I want to talk a little bit today just about why I think animation is really great and why it's super useful, and just sort of showing off gganimate and just how simple it makes it for making animations yourself. And really, it makes it so simple that I even use animations sort of as part of my exploratory data analysis process because oftentimes it's as simple as just adding a single line of code. But first, before we get into that, just talking about animation a little bit more generally, something that I run up against when I'm plotting data and trying to explore data and understand data is this sort of lack of dimensionality in terms of the ways that we can show information. So if you use ggplot in R, you're probably familiar with this idea of ggplot stands for the grammar of graphics, right? We have these sort of dimensions that we can interact with. And so there's sort of the obvious ones, right? The X and the Y dimensions, but color is also a dimension that we can map information to. And it's something we often will map information to. Shape is another one, but at a certain point, it gets really hard to fit more variables in your plot just because it gets too complicated. It's hard to parse sort of what's going on. So that's why I really like animations, because it gives you access to an additional dimension, right? We now have a time dimension which we can use to show information that otherwise would be hard to represent, and it allows us to focus our audience when we're sort of creating an animation for other people. We're able to focus our audience to sort of like a particular part of the screen, a particular couple of points in the data we're particularly interested in. It just makes it so much easier to control how your viewer is viewing your plot if you're only showing them a piece of it at a time. So anyway, I'm just going to start here in an empty R Markdown file, and it's going to be similar to last week. I had a good time last week sort of building our Shiny app from scratch without really having a strong plan in place. And so we're going to do the same thing today. We're just going to go ahead and start building a simple plot here. And I'm going to show off a couple of the different functions that gganimate gives us access to. But really, my goal is just to sort of encourage anyone who's watching this to play around a little bit, try introducing some animations into your data processing sort of pipeline, or in some of your presentations for others. So anyway, I'm going to go ahead and use the iris data set. It's just my sort of go-to for everything I do, just because it has a couple numerical variables. It's sort of obvious what's going on, and then there's the categorical variable, which is useful. So basically what I'm going to do here is I'm just going to start by creating a very simple ggplot, static, sort of nothing special going on. And then we'll see how we can sort of iteratively build from that starting point of a static graph until we have sort of something that's nice and animated. So data equals iris, and let's just go ahead and plot petal lengths and widths. So I'll put petal length on the x-axis and petal.width on the y-axis. I'm just going to go ahead and put those names in there just so it's clear what's going on. And we'll just start with a simple scatter plot. Okay, so we have sort of our most basic, simple plot that we can make with this data, simple scatter plot. You can see there's some different groupings. So we have this dimension, right, color, that we can use to represent information, right? So we can represent the species information on our scatter plot, right? And so just like the x dimension is a dimension that we can plot information on, the y axis is a dimension we can plot information on. Here, the information that's encoded using colors is not represented any other way in our plot. We're using color as a dimension to show information. So let's go ahead and turn this simple static plot that we have here into an animation. The first thing you need to know about gganimate is that there's basically all of these transition functions that you can use. And these are really the sort of like primary driver of the animation, I guess I'll say. The transition is very much the meat of your animation, similar to sort of your first ggplot line. It's kind of setting up the stage. A lot of the other functions that we're going to be looking at are just kind of doing some small adjustments or adding some additional sort of theming and things to our plot. So you're usually going to start with a transition function, and there's two kind of big ones. Well, three. There's transition manual, which is sometimes useful, but most of the time the ones that I'm using are transition states and transition time. So transition time is useful if you are specifically setting up an animation over time. Here, what I'm going to do is just have the different species kind of pop up separately. And so because the data I'm going to be representing is the species data, which is discrete, I'm going to use transition states. Okay. Cool, so we have our transition states function, and now all we need to do is tell gganimate what we want to transition over. So we'll just put species here. So you can see this sort of fits nicely into the sort of flow of creating a ggplot, right? It's a function that's being added on to what you already have. From here on out, we're just going to sort of keep adding our animation customizers sort of after this point. But the first step of creating a gganimate plot is to create just a simple static ggplot that sort of contains all the information that you want it to have. So, okay, let's see what happens now that we've added this transition states. One thing to know is, especially when you're sort of like working in R Markdown and working interactively, this process is going to be a lot slower than creating a static plot, because what's happening under the hood is we're basically creating like 100 static plots and then sort of stitching them all together. So it'll take a little bit to render. Depending on how much data you have, it could take longer. You can see we're now sort of getting some output here. The default is 100 frames, so once this gets up to 100%, we should have our animation. So let me go ahead and move myself up here for today because we're going to be looking a lot at this viewer. So there you go. As simple as that, adding transition state species allowed us to sort of like create a small dynamic animation. It's pretty cool how sort of straightforward it is. This isn't sort of getting the full power out of animations, right? Because this is an example of a plot that doesn't need to be animated. And this is like a danger of animation. You don't want to have plots that don't need animation and make it hard for your audience to figure out what's going on. This is, probably an example of that because your audience probably is interested in just comparing all the species at once, and color's plenty good at doing that. But for our purposes today, this is going to be good enough just to sort of see a bit of the power behind gganimate, and hopefully you can sort of work out for yourself whether animation is actually needed in your plots or whether something like color or size would work well enough. Okay, so next I just want to show some of the options here in transition states. One of them is transition length. So this has to do with how long the transition is going to take. And then there's state length, which has to do with sort of how long the pause is going to take. And then there's wrap, which determines whether your animation sort of goes back to the beginning. So let's go ahead and just play around with one of these state length, just to show sort of like how straightforward it is to change some of the really basic aspects of your plot. So again, we'll sort of like take a minute for this to render. I find that this time is usually worth it, although something I will do is this default 100 frames is really more than what you need for building plots when you're just kind of doing something exploratory and you don't really plan on showing the plot to anybody else. I would go down pretty significantly, maybe down to 30 frames or something like that, especially for an animation like this where we really don't need a high resolution. There's no real transition happening yet. But okay, our plot is now ready. Our animation is now ready. And so it's basically the same, but hopefully you notice there's a bit more of sort of like a pause on each of these states, right? So our states are these three species, red, green, and blue, and you can see that the time before switching to the next state is a little bit longer. So ggAnimate gives you access to this sort of control very sort of simply. You don't have to really dig deep to change some of these basic things. When you try to do more complicated stuff, ggAnimate can break down a little bit. You probably need sort of like a more full-fledged software, but for simple stuff, I just find this to be incredibly useful. Okay, so we have sort of our very simple plot here that we're going to be working with. Let's go ahead and talk about our next concept, which is views. I'm going to go ahead and get rid of this state length here. Views determine the frame around the data, I guess. The coordinate space around the data and how that changes. So right now, because we haven't defined a view or anything, the view is set up to just sort of be static and unmoving. But in a second, we'll see sort of how to get this nice effect of actually sort of like moving with the data. Okay, and this is one of those things where you have to be a little bit careful not to overuse it or use it in the wrong spot, because like very quickly it can be hard to tell what's happening to the scale. But sometimes this is like a really useful technique for getting a more like emotional effect of your data. If there's sort of like a really big increase, having the view change and watching sort of the scale of all of the other data kind of go to nothing. It's very sort of like emotional thing that you can really only get out of an animation. You can't really get that effect out of a static plot. Okay, so I just want to point out before we're going to use view follow here, but just like transitions, there's like a few different functions here, and you would basically choose whichever one fits your situation. But let's go ahead and use view follow just to show how this works, and then we'll do the same thing where we just kind of show a couple of those arguments and what they do. So, okay, we'll just give this a second here. If anyone's watching, go ahead and just say hi in the chat. If you're watching this sort of after the fact, if you have any questions or anything, leave a comment on the video. Happy to sort of get your thoughts. Are these tutorials useful? Should I keep making them? Questions about R, trouble you're having, questions about gganimate. Happy to sort of answer all that stuff. All right, so give this just another second here to finish up the last few frames, and there we go. Okay, so it's sort of not clear exactly what's happening, maybe at first. What you should watch is the y-axis, right? Watch how sort of those numbers change. Because we have like discrete states, we're not getting this nice effect of like sort of slowly moving, but that's what you would get if you had data that was like sort of set up in that more continuous space. But you can see for each of these species, we've sort of focused to the box that specifically contains just those data points for that species. And so the scale sort of changes appropriately with each of these states. And I mean, if you've tried to do animations in other software, hopefully you're sort of thinking to yourself, like, wow, that is pretty straightforward. Because to me, I mean, this is the sort of thing that would be really hard to do without gganimate. If you were sort of building all of the PNGs and stuff yourself. Okay, so let's go ahead and show, you can see there's this sort of fixed X and fixed Y here. So let's go ahead and show one of these. And this is a situation where it's easier, I think, just to show it than to talk about it. But basically, you can prevent one of the scales or both of the scales from being modified, although I don't know why you would want both to not be modified. So we'll go ahead and see sort of what this is doing in a second. There's also this exclude layer, which sort of gives you like some finer grain control. And then there's aspect ratio, which, you know, as you might expect, it controls the view to sort of like keep a specific shape the whole way through. So anyway, just like in the transition functions, there's sort of these helpful controls that allow you to just do common tasks. And really you don't have to think about it, which is really helpful. Okay, so we'll let this render for another minute. If you're wondering, how do I actually save this? How do I get access to it? We will be talking about sort of rendering these animations and sort of the best ways to do it. I usually will have them output as a GIF, which is a pretty general file format. But there's some setup involved in sort of generating that output that's worth talking about. So we'll be talking about that at the end. Okay, so hopefully you see sort of what this fixed X argument is doing. If you watch the X-axis, the numbers are staying the same. They're not moving. We just sort of see the data appearing kind of across the x-axis, whereas the y-axis is still sort of dynamically changing based on the actual data that's being displayed. Cool. All right, so I'm going to go ahead and get rid of that, just because I want to show kind of one thing at once. But let's get into talking about some of the fine-grained control of the transitions. So this is like generally called tweening. There's an R package, which I think is called tweener. Let's look that up. Yeah, so there's this package, tweener, that gganimate is sort of using under the hood to do some of this work that allows just simple transitions and different types of transitions. So let's go ahead. Let's see. Let's just go with enter appear. Let's do enter fade and exit fade as well. And so most of the stuff that you want to do with tweening would involve either one or both of an enter function and an exit function. So these are just different transitions that are available to you. So let's go ahead and let's do drift. Trying to remember which this one does. I usually not too focused on the actual transitions. Like I said, most of the stuff that I do is actually kind of more exploratory, so I'm usually not thinking too much about this stuff. I'm usually just trying to get what I want out of a plot, and then I'm done with it. But even when I am making a plot that I'm planning on showing to other people, I'll often just kind of keep it simple with the appears, for the same reason that, like with slides, I usually don't use fancy transitions. But if you sort of really want to put a lot of work into your plot and make it sort of as visually appealing as possible, definitely you want to play around with some of this stuff. Let's go with exit fly. I think that's a pretty fun one. Go ahead and run this. All right, so let me stop that real quick and just let me recall. I think I need to give an X lock and a Y lock here. I'll just set those both to 0. All right, so give this a second. All right, so should start to render the frames in about a minute. ggganimate has to do a lot of work under the hood to sort of figure out how to apply your transitions and things. So the more complicated of an animation you're trying to make, the longer it's going to take, unfortunately. Okay, cool. So here's our sort of silly little animation that we created. You can see, compared to earlier, we had this sort of like direct appear and disappear. Now we have this sort of nice like fade in, and then fly is a little bit silly, but the data just kind of moves to whatever point you've indicated with X lock and Y lock. So each of these enters and exits are going to sort of have their own parameters. So you can see the fade has alpha, but fly wouldn't have alpha because there's no sort of transparency happening. Instead, fly has the position that you're sort of sending the data to. Cool. Okay, so that is honestly, 90% of the things that I mess around with when it comes to using ggganimate. Like I said, there's other transitions and things, but for my purposes, I found that transition state and transition time are sort of the primary ones that I use. And then sometimes I'll play around with a view, and very rarely, if I'm really putting a lot of effort into it, I'll mess around with how the transitions actually look. There's one more thing to show here, and I think it will work well with our transitions here. Now that we have something a little bit more exciting happening, we can show this off. And these are shadows. So shadows allow data to be shown on frames of states that data does not belong to. So basically, if we want sort of some lasting effect of data to be shown in sort of future frames, shadows can allow us to do this. So let's go ahead and just put shadow trail here, and I think this will work for us. Go ahead and run that. And then I think you'll be able to see what I'm talking about here. In this particular instance, because we're going to be just applying a shadow to our transition, it's not going to be particularly useful for representing data. But when you have continuous data, for example, if you're actually showing something over time, it can be really, really useful to have previous states still on the plot in sort of the original location or the previous location or the previous 5 locations, because it gives the viewer something to compare to, right? If you're going from one position to another position, and you sort of want this comparison to be drawn, it's useful for the viewer to just have like a little visual indicator of where the data actually came from. Okay, so what's happening here is not super clear, but basically each frame is leaving this shadow, right? So this is where all of the data is sort of being placed on each of these frames, and the shadow sort of allows those points to be like kept in that location. So, like I said, not at all obvious like why this is actually useful in this particular example, but in many cases can be very, very helpful. So let's go ahead and show just one more shadow function here. So we'll go ahead and do shadow wake, which takes a wake length, and let's make that relatively low. So 10%. And hopefully this will make it a little bit more clear what's going on, because our current shadow trail just kind of makes it look like more data is being added for some reason. So hopefully shadow wake here will be a little bit clearer how you might actually use something like this. You can use shadows also just for sort of visual effect. It's not necessarily just a way of sort of showing previous useful information that you want in the future. That's just sort of what I tend to use it for. All right, so a couple more frames here. Okay. So I can't tell if our shadow wake is actually doing anything. Let's see, we might have to show proceeding. Right. Right. So shadow wake is actually showing previous frames, but it's hard for me to tell that apart from the actual transitioning that's happening. So let me actually just turn this off for a second. Let's just do this. It'll be a little bit easier to see if this is actually having an effect. Let's just make this 0.5. Okay, so now we should be able to tell our shadow points from our actual transition data points, assuming our shadow is actually doing something here. Should be done soon. All right, so let's see if this had an effect. All right, so you can see we we get these little shadows showing up here, which are sort of following with the transition, although not really. So maybe we would go back to our shadow trail, and then we could sort of mess around with some of this stuff if we wanted to do that. This is really not the type of plot where I would be adding shadow anyway. So instead, what I think we'll do is let's just go ahead and take these lines where we have our transition and our fly, and let's go ahead and let's show one more exit off. Let's go ahead and do shrink. Okay. And now sort of the last thing that I want to show here is how to actually render and output these animations. So just like a normal ggplot plot, what's actually happening under the hood here is that this object is being returned, and our markdown is sort of helpfully printing it out for us. But we could just as easily, instead of printing it out directly, save it to an object and then sort of print that object out. So we'll let this finish, and then I actually want to sort of explore this anim object that we've created and sort of see what's in there. And then we'll go ahead and actually spit it out, and we'll open it up so that we can sort of take a look at it and prove we can actually use this animation outside of our studio. Okay, so we now have this object anim, which is still going to be printed over here because I've sort of left it as the last item in this chunk. You can see we have our new exit where these points kind of shrink to nothing. And now let's go ahead and just sort of take a look and see what's actually in this list here. So we have this data item. This is, as you might expect, the data that we are sort of working with here. But it's actually saved inside this animation. Layers is sort of basic ggplot information. We don't have to look sort of too much at that. Scales, mapping, theme, coordinates, facet, these are all sort of additional ggplot pieces of information that sort of refer to the static plot. But in here, this is sort of the magic, right? The transition, information, the view information, the shadow information, all of this stuff is sort of being stored all in here. So you can see really what this is just kind of like a specification for the animation. So there's nothing really like fancy about this list. What happens is we send this to a renderer, which is going to sort of parse this and figure out what to do with it for us. So I usually use the gifski renderer. So let me go ahead and sort of show. Let me go ahead and show how this works. So we're going to work inside either this animate function. So we can animate this object, and this is basically what's happening up here, just sort of implicitly. Or we might use animsave is sort of the other option that you would use. So while this is sort of rendering, to just sort of show that this is the same as what was happening previously, let's go ahead and just show how to use this animsave function with our gifski renderer. So I'm going to go ahead and make my animation.gif as the file name. You can see in this chunk, this is the exact same output we were getting before, right? It's the exact same call. So hopefully that sort of shows what's going on a little bit under the hood. This animate function is being called. But most of the time, if we want output, we're going to use animsave. So animsave is going to take the file name and then the animation. You don't have to even explicitly put this in. It can just find your last animation that you made, but I think it's good practice to sort of save these to objects, especially if you don't plan on actually displaying them. If you're not working interactively, you don't want to bother sort of rendering them twice if you don't have to. Okay, so everything else is sort of a property of animate, and there's a few that are useful, so I'll go ahead and show those. End frames is useful if you don't want it to take so long, and all these arguments I'm going to give here, right? You could also put you do something like this. So if I was sort of having a problem with how long something was taking, I would change sort of just having this on its own here to actually explicitly calling animate myself to be able to control some of this stuff. But end frames will reduce both the size and the size of your animation and also the amount of time it takes to render. There's also FPS and duration, and so those three arguments sort of combine together. You don't have to set them because there's a default end frames and a default FPS. But if you want to sort of control those values specifically, you would choose sort of two of those to set. And then the next big one is renderer. And I, like I said, use the gifski renderer. I believe this is default, so you don't have to sort of explicitly set this yourself, but knowing which renderer you are using and having sort of like a good reason for choosing that one is a good idea, because whatever renderer you're choosing is going to have to interact with sort of the rest of your environment beyond just R. So if you want to make sort of movie files instead of GIFs, there is the FFmpeg renderer, I think, if I remember correctly. Let me go ahead and make sure that's right. No, there's a list of them here somewhere. Yeah, FFmpeg renderer. So I use that if I want videos for some reason instead of GIFs, which is sometimes useful. There's also the magic renderer, where magic is MAGICK, which is like a common like image processing library that is incredibly powerful, that I've used to make GIFs before I started using gganimate. And all of those renderers and the other options that you have all come with sort of their own options and their own arguments and all that. So you sort of want to be aware of which one you're using, and you want to be aware of the requirements of each of your renderers. So GIFski renderer, the first time you do this, this will sometimes ask you to install the PNG-R library, if I remember correctly. So you might get an error about that, and then you'll have to go ahead and install that. Let's see if there's any other arguments that I want to touch on here. There's one more that I find myself using fairly frequently, or rather a pair of arguments. There's start pause, which is sometimes useful. Here I'm going to show end pause, and we can set that. Let's just go ahead and set that to 5. And so what this is going to do is actually, whether you use start pause or end pause, keep the sort of final frame or the first frame and just kind of hold it there. You're basically duplicating that frame however many number of times. And this is really useful if you want to give your audience a second to kind of adjust and orient to your plot before you start moving data around. So I end up using these ones a lot. Those are sort of the only other animate arguments that I find myself using frequently. I am going to put the excellent documentation in the chat. ggganimate.com is really useful. It has sort of really great examples for doing all this stuff. So if you are interested in using ggganimate and sort of want to learn some more about it, definitely recommend going over to ggganimate.com and just sort of looking at the full reference. Okay, cool. So I'm going to go ahead and clear this. Our animation has saved to this myAnimation.gif. So let's actually look. I think this is just probably sitting in my home directory somewhere. Let's see where this went. Okay, it's on my desktop. So let me go ahead and show this. I will go ahead and open myAnimation.gif, and here it is in Chrome. You can see we have our sort of full animation. It's pretty speedy, right? We set it down to 30 frames. It didn't change the duration, so it's going a lot faster now. But you can sort of see that pause right at the end where these sort of blue points are still visible. That is our end pause. Okay, so that's pretty much what I had for today. Hope you enjoyed that look into ggAnimate. If you use ggAnimate or like it or think it's cool, love to hear about it in the comments. Other than that, I'll see you next week, Wednesdays at 5 p.m. Chicago time. If you have any topics you'd like to discuss, let me know. Currently undecided what we will be doing next week. So yeah, let me know in the comments, or we have a request form uh, in my page's description as well, if you want to suggest topics. All right, well, that's all for now. See you guys next time.